Alright, in this slider example, we've got this pin connected bar, load W, we have a little cable that wraps around. We have no friction that we're going to model in the system with these sliders. That definitely makes everything a little bit easier. You pull out the model, or the bar, AB, there's A, there's B, put the imposed weight W, looks like it's probably in the middle. You have then a horizontal only reaction at A and a vertical reaction only at B. That's pretty interesting, right? Determine the value of the angle required for static equilibrium. Well, that's kind of interesting. Oh, wow. You know, I was kind of stymied there for a second because I'm thinking, hey, wait a minute, there's no way I can get this, these two will intersect here and I don't have any equilibrium. Well, that's because I neglected the tension here and here, and so now that looks to me like I can say AX must be going this way. And what do I think is going to happen? Well, if that's the case, what I think is going to happen is that the line of action of W is fixed. That's up here. And these two are going to resolve themselves to be something like this. And these two will have to resolve themselves, I guess, to be something like that. That makes BY going upwards. I don't know if I like that or not, but it's going to be something of that sort that we're dealing with. I guess so. And so now all I have to do is figure out how that all works. Huh. That's your simple free body diagram here, right? And now the equilibrium, or the angle for static equilibrium, this has to work this way. If BY goes to 0, BY goes to 0, then this thing is at, I guess, 45 degrees. I don't know. This is really interesting about, well, how does this work? Well, alright, let's some moments about point A, and let's see what happens. Right? We're going to assume W is at the center of mass, so when we do this, we'll get minus W, and then its moment arm is going to be L over 2, L over 2 times cosine theta, assuming it's in the middle. Yep, that's right. And then we're going to have minus, that'd be plus T times, let's see, that would be sine theta, L sine theta, plus BY L cosine theta equals 0. That'd be one equation. Some moments about point B, and we're going to get, well, we'll get plus WL over 2 times cosine theta. We're going to get then plus AXL times sine theta, and then minus T times L cosine theta equals 0. So that's two equations. Our unknowns are T, BY, and AX. So what would be the third one? It would be this one up there. Now that looks really ugly, frankly, if you ask me, so I'm not going to do that one. Instead, I'm going to sum forces in the X, and I get a nice trivial one that AX minus T is equal to 0. Ooh, I like that. Notice here, I'm not going to solve all of this. I'm going to let you play it out. I've set it up for you. But AX now equals T. And if we substitute in here, all the L's, by the way, are going to cancel out. So we'll have W over 2 cosine theta plus AX sine theta minus AXL, got rid of that, cosine theta equals 0. So let me be careful here. Here's equation 1, here's equation 2, here's equation 3. I sub in to 2, and we get this one. We'll call that equation 4. right? Looks ugly. I don't particularly like this, but it is what it is. If we go up to this top one, sub into 1, then we'll have, again, the L's go away, and minus W over 2 cosine theta plus AX sine theta plus BY cosine theta. Again, I've divided by L already. That'd be equation 5. Add those two together and those go away. That's interesting. 2AX sine theta minus AX cosine theta plus BY cosine theta equals 0. Divide by cosine theta and you have 2AX tangent theta minus AX plus BY equals 0. Doesn't really particularly look all that helpful, but what it does do is get us the ability to get BY in terms of AX. So BY equals 1 minus 2 times tangent theta AX. And so now you could substitute in again. Now this, this looks ugly. I don't think this is the particularly easiest way to do this. It is a way. When I see sines and cosines running around, I start thinking about maybe I could multiply some things here by the same thing, so I could get a sine squared and a cosine squared. But ultimately, we got to solve these simultaneous equations to find equilibrium. Looks ugly, huh? Yeah, this is a hard one. At least initially, to do it this brute force way. Stay tuned in case we might find out a simple, elegant way to do this. But this is the basic setup that we're working with.